Yo, 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 youngsters, we're looking at the last two sections of chapter 5, 5.5 and 5.6, where we're solving exponential and logarithmic functions. In this first one here, we have to make sure that we have any exponential portion of it by itself. So we see we have this plus 3 and this 8 that we're multiplying. We need to get rid of that. So we subtract that 3 from the 8, we get 5, and then we divide that by 8. Now we have it in a situation where since it's base e, we take the natural log of both sides, since that is the log base e function. And in doing that, we can now rewrite this as 5x is equal to natural log of 5 over 8. And then we just simply divide by 5. Next problem here, same thing here. We need to divide by this 2. That's how we get 3. And then we can just rewrite this as a logarithmic function. And that allows us to solve when we get x is equal to log 3. Here we need to divide by 3 first. That's how we get this 2. And then since this is log base e, or natural log, we can just rewrite it as an exponential and then solve for x. Here we want to use a logarithm. We can use any log base, but I'll just use base 10. As long as the bases are the same, allows us to have this, and then we can say, using that rule, then we can solve for x. The hardest part might be just plugging this in, so be careful when you're plugging this in. And next up here, we're just using logarithm just like we did before. This allows this x to come down, and then we have this. Here, more of the same. We need to divide by this 2 first to get it by itself. Now that we have it by itself, we can take the logarithm. And then once we have this, we can see this exponent comes into the front, allows us to divide by this, and then we just have to add here. Next one here, first things first, we have to divide by the 3 to get 4, and then we can just write this as an exponential. Since this is natural log, it's base e to the 4th is equal to x. Here, we can just go ahead and write this one as an exponential, and then we can solve for x by dividing by 2. Next one, we can go ahead and write this as exponential. We know that it's log base 10, so then we can say 10 to the 1/2 power is equal to 12 minus x. 10 to the 1/2 power is the same as the square root, so all I did was add the x over here and subtract the square root of 10, and we're done. Here we can just write this as exponential. So 2 to the 4th power is equal to 6x minus 6. 2 to the 4th is 16. Add the 6, I get 22. Divide by 6 and reduce. I can just go ahead and write this as an exponential. 2 to the 4th is equal to x cubed plus 15. 2 to the 4th is 16. Minus 15 is 1. Cube root of 1 is 1. Here we're adding here, which means we're multiplying the x times x squared, which gives us the natural log of x cubed. Then I can do the exponential of both sides, so e to the 3rd power is equal to x cubed. Solve for x by taking the cube root, I get e. Next up here, I'm adding here, so I'm multiplying x times x minus 15 to get x squared minus 15x. Now I can write it as an exponential function, so 10 to the 2nd power is equal to x squared minus 15x. 10 squared is 100. Then I can factor this. And here we have an issue where we have an extraneous solution. So if we put in -5 into the original solution, we cannot have a log base anything to a negative number. And therefore, our answer is only 20. That'll happen a couple times. And here, we're subtracting, so that means we're dividing those things. And then we can just say that this is equal to this. Solve for x. Here we're adding, which means we're multiplying x plus 3 times x minus 3, which is x squared minus 9. 3 to the 3rd power is 27. Solve. Now I get -6 and 6, but -6 would give me a negative number inside there, so it's only positive 6. Here we're subtracting, so that's 8x over x plus 4. Same basis, so I could set those things equal to each other. Multiply here, so I get x squared plus 4x is equal to 8x. Solve. Factor. 0 I can't put in, so therefore 4 is my only solution. I am dividing here, therefore I. And this one we can kind of look at here. Natural log of e to the x is x. Here, this is 8, and natural log of e to the ninth is 9, so it becomes very simple. Then here we're looking at the half-life of mummies. And so here is the setup here. And just like the equations before, we're just taking the natural log of both sides. Since this is base e, it allows us the exponent to come down, and we can just divide. Make sure you round correctly. Here we're looking at 16%, so instead of 1/2, we have 0.16 here. Already gave us this equation. Natural log of both sides allows us to get the exponent down and then divide. Make sure you round correctly. And this last one, we're looking at basic half-life function. So we have a sub 0 is looking at some type of initial amount, and 1/2 is the half-life of that, to the negative kt. So this is decay, so this needs to be negative. So watch out for this, because when you solve in this first one, you'll end up with a positive number here, but you'll need to put a negative here. In the second problem, we're looking at starting with 400, and I want to end up with 300. So that's how the setup is, and I'm using the equation I got from the first part. Take the natural log of both sides, solve, make sure you round correctly. And the last one, the way you set it up, you just put that into your calculator. So we're looking at 400 grams of the K that we found in the first part, and after 10 years, and make sure you round correctly.